Well, grade 11s, welcome to Cell School. In this lesson and the ones that follow, we're going to be doing trigonometry. Okay, now trigonometry is obviously considered quite difficult, but it's actually very simple. In grade 10, we spoke about, if you look at this triangle, if you look at the angle theta here, if you remember, the side here would have been opposite angle theta, this side there. This would be the hypotenuse if it's a right angle triangle, and if you remember, that was the adjacent or the next to side, opposite and hypotenuse. Now, the other thing I want to show you, if you use a Cartesian plane, and let's suppose we make up a point 3 and 4. Okay, 3 and 4, and that's naught, and let's call that point Q, say. If you think about this, this is the radius of the circle, and if you look at this, if we think about it carefully, x is 3 units, so that's going to be 1, 2, 3. Alright, 3 units, so that side there is actually 3 units. So I'm just going to move the adjacents out the way for a bit there, and so we just have a bit of space, but this is going to be 3 units there. So that x value is represented along the x-axis. It's the horizontal distance from naught there. Then 4, if you think about it carefully, 4 would be, if we go up here, 1, 2, 3, 4, 4, that distance there, this distance is 4 units. So if you go across here, it's the exact same height there. So that would be 4. So the y value is the vertical side of the triangle. The horizontal side of the triangle would be the x value, you can see there. And the r, well, that's the radius. We could use Pythagoras to work it out. And if you remember, x squared plus y squared was equal to r squared. So if you think of the radius, what we could say is, well, look at this. That's x squared plus y squared is r squared. So 9 plus 16 is 25 is equal to r squared. So the radius, if you square root the 25, you get 5. So the radius here is actually 5 units. So let's write it in there. Okay, so now we've got an interesting connection. You probably remember from grade 10, if I said to you what was the sine of theta, you would say opposite over hypotenuse. If I said to you what is the cos of theta, you would have said adjacent over hypotenuse, and the tan would be opposite over adjacent. Remember, oh heaven, another hour of algebra. That's the way we did it in grade 10. Oh heaven, another hour of algebra. Sine, cos, tan. So if you look at this, what is opposite? This is the opposite would be 4 over 5. This would be the 3 over 5. And this would be 4 over 3. You see that there? Now remember, this is the opposite of the hypotenuse. But if you think about it, this is actually here. If you actually think about it carefully, this is the r for 5. That's the 4 is the y value, and the 3 is the x. There's x, and there's y. So you could say that this is sine is y over r. This is x over r, and that's y over x. Y is 4. And x is 3. So we've got some new definitions for the trig ratios. Instead of opposite over hypotenuse, we can use y over r. So what we really now need to do is to go away from the actual value 3, 4, and let's generalize a little bit and see what we get. Okay, let's look at the situation. Here's the radius of the circle. We've got the y. Remember, y was the vertical side and the horizontal side is the x, and we already know from Pythagoras that x squared plus y squared is r squared. That in fact is the equation of the circle, but don't worry about that. But now people, what we now know, and I think this is so important, is that we've got new trigonometric ratios, and how it works, if you think about it, is the sine of theta is going to be opposite, look at that, opposite over hypotenuse, which is going to be, if you think about it carefully, that is going to be y over r. The cos of theta is x over r because that's adjacent over hypotenuse, and the tan of theta is y over x, which is opposite over adjacent. Just remember, oh heaven is for sine. That's O heaven, opposite over hypotenuse, another hour, I love this, another hour, which is cos, there it is, adjacent over hypotenuse, look there, adjacent is x, hypotenuse is r, of algebra, okay, and that would be over a. O over a there, look at that. And that's going to be tan, opposite over adjacent. So we've got sine is y over r, cos is x over r, and tan is y of x. They're new definitions, but they really relate to, oh heaven, another hour of algebra. Okay, now, in trigonometry, remember we spoke specifically about a point, and that point belongs to a quadrant. Now, there's actually 4 quadrants in trigonometry, and this guy where we are now is quadrant 1. This guy is quadrant 2 here, and I'll explain it to you as we go along. Quadrant 3 and quadrant 4. Now, we're going to talk about these different quadrants. So, I want you to bear in mind the sine, cos, tan, the new definitions, and as well as the old. But now, let's have a look at, if we go to quadrant 1. Now, I've picked that point that I used before. Okay, now, how's this going to work? If you look at this point there, let's just draw it in there, point. We know that that is x and that is y. All right. The vertical side is the y, and the horizontal side is, of course, the x. But also, what do you notice? Something very important about this is that you're in what we call the first quadrant. Okay, now the first quadrant goes from 0 to 90 degrees, and how we can write it is like this. We can say 0 to 90 degrees if you want to, like that, or you can go and write it with that set builder kind of notation. This is more interval, and this is all in the first quadrant from 0 to 90. Okay, and we say that if you look at this angle theta, it could be anything between 0 to 90. So what we would then use, instead of x, we could use theta, because we're talking about the angle being in that quadrant. Okay, so there it is. So theta is an element of this thing. Okay, and here we go. So, and what do you notice if you look at this? In the first quadrant, the x values are positive, but so are the y values. So the x's are positive, but so are the y's. Now, if I go, and what I'm going to do is I'm going to take this across here. In other words, I'm going to reflect that point across this y-axis, and it'll be exactly the same. And what you're going to get is you're going to get another triangle here, where the x is negative 3, and the y is 4. Now notice, the x is negative and the y is positive in this quadrant. Okay, so very important here, we displaced this way. The vertical would be 4 and the horizontal would be, we're displacing to negative 3. Okay, the distance is 3, but we kind of, on the side, we're moving this way, okay, in that direction. Now notice your angle is what we call obtuse. Okay, it's an obtuse angle, if you remember that word. And an obtuse angle would lie from 90 to 180. So you could say that the angle could lie from 90 to 180, or you can make it like this. You can go 90 less than theta less than 180. So this is what we call the second quadrant. And in the second quadrant, x is negative, y is positive. The angle goes from the positive x-axis, it goes obtuse. It would be something like, you could, like for example, 120 degrees would be in this quadrant here. It's bigger than 90, less than 180. And you have, if you take that point which we reflected across here, the x is negative but the y is positive. So hold on to that concept. If you remember first quadrant, x is positive, y is positive. But in this quadrant too, the x is negative and the y is positive. Now, if we drop this down, if we go down, you'll notice something interesting. If we bring that down, if we just reflect that, what's going to happen here in the third quadrant, this is quadrant 3, which goes from 180 degrees to 270. Now, look at your angle. You could also do it like this if you want to. But this is quadrant 3. You'll notice that the angle is reflex. So that will be something like 220 degrees, which is bigger than 180 but smaller than 270. But notice here, if you take that point, remember the vertical side is the y, which is is negative 4, and that's negative 3. We displaced this side and this place. The distance is 4, the distance is 3. But notice that the x is negative and the y is negative. So your x is negative and your y. Hold on to this. And if we carry on, if we now reflect to this side, x is positive, y is negative. Okay, this is called the fourth quadrant, and it goes from 270 to 360 degrees. Okay, again, you're talking of reflex angles. An angle, for example, this theta, if you go 315 degrees, you're less than 360, but you're bigger than 270, and you are in the angle is said to lie in this fourth quadrant here, where x is positive and y is negative. And so in the third quadrant, both x and y are negative. The angle's reflex, the angle lies in the third quadrant, bigger than 180, smaller than 270. In the second quadrant, the x is negative, the y is positive. It's obtuse. The angle lies between 90 and 180. If you're an acute angle, this is called an acute angle. You're in quadrant 1, and guess what? You are going to definitely be positive and positive for x and y. Okay, so that's the important thing with these diagrams, but I want to summarize all this now. Let's have a look at this. In quadrant 1, the x's are positive and the y values are positive, and we go from 0 to 90. Here, the x's are negative and the y values are positive. Here, the x is negative, the y is negative, and over here, x is positive, but y is negative. Now, I want you to hold on to that, of these particular signs for x and y in the different quadrants. And we're going to now look at the trigonometric ratios and see what happens to the angle in each quadrant. Okay, stay with us. Okay, so guys, let's just quickly recap this again. X positive, y values positive. In the second quadrant, x is negative and y is positive. Because if you pick any point there, as we did before, you can see x is negative, y is positive. Here, x is negative, y is negative, and x is positive, and y is negative. Now, I want us to look at quadrant 1 quickly. Okay, we're going to look at quadrant 1. Okay, now we know that the x is positive, the y is positive. And by the way, the radius of the circle, the radius, if you've got a radius going there, it's positive. If it's going there, or wherever this radius is going, the radius is always positive no matter what quadrant you're in. So the radius is always positive. But the x and y could vary in sign. So in quadrant 1, you've got that. Now watch this. The sine of theta is y over r. We did that before. Now sine, if you look at y, it's positive, a positive number over a positive radius, which is positive. Okay, the cos of theta is x over r. The x is positive, the radius is positive, plus over plus is plus. And the tan of theta is y over x. Okay, now that's again is plus over plus, which is plus. So you look at these guys in quadrant 1 and you say, okay, fine, x is positive, y is positive, r is positive. So you agree that all these three are positive in quadrant 1. Now let's go to quadrant 2, and okay, we know the r is positive, but x is negative and y is positive. Look there again, x is negative, y is positive, r. So using those values, let's see what happens to the trig fractions or ratios. Sine is the y over r, opposite over hypotenuse. Okay, so the y is positive, the radius is positive, and plus over plus is plus. Then we've got the cos of theta is x over r, and that's, now watch this, this is interesting. The x is negative. Okay, so the x is negative and we're dividing by a positive radius, giving us a negative. The tan of theta is the y over x, opposite over adjacent. The y is positive, but the x is negative. So plus over minus is minus. Now notice, sine is positive in quadrant 2, but cos and tan are negative. Okay, let's go to quadrant 3. And what do you notice? In quadrant 3, the r is positive, both the x and the y are negative. If you go and have a look at that. Yeah. Alright, now, let's do the trig fractions quickly. The sine of theta is y over r. which is going to be y is negative over the radius, which is positive, which is negative. The cos of theta is x over r, which is negative over the positive. X is negative, r is positive, which is negative. And then we've got the tan of theta, which is the y over x, which is going to be negative over negative, y over x, and minus over minus is plus. And so you'll see tan is now positive there. What about quadrant 4? Okay, quadrant 4, in this quadrant, the r is positive, the x is positive, but the y is negative. There we go. You can see it from here. X is positive, y is negative, but r is positive. And if you look at the trig ratios here, sine theta is equal to y over r, which is the y is negative over the positive radius, which is negative. The cos of theta is x over r, which is positive over positive, which is positive. And the tan of theta is the y over the x, which is the y being negative, the x being positive, and there you have it, it's negative. So I'm going to circle, I want you to look at this, there's a pattern here, and we're going to summarize all of these in a moment. Okay, have a look here, guys. I'm just going to circle this quickly. If you go to quadrant 1, if you notice something in quadrant 1, all are positive. All the trig ratios are positive. When you get to quadrant 2, sine is positive. The other two are negative. When you get to quadrant 3, tan is positive, but the other two are negative. And if you get to quadrant 4, you'll notice that cos is positive, but tan is not. Okay, and sine is not. It's negative. So if you think about it, we can summarize this as follows. Okay, let's summarize this as follows. In the first quadrant, all the three trig fractions ratios are positive. In the second quadrant, remember sine was positive, but cos and tan were negative. Go and have a look at that in quadrant 2. Sine is positive, but the other two are negative. Then in quadrant 3, it was tan being positive, the other two are negative. And in the fourth quadrant, cos is positive, but the other two are negative. And sine is y over r, x over r, y over x. Just remember that.